Karibu SolidWORKS Tanzania. Ni matumaini yangu umekuwa na vipindi poa sana vilivyopita. So sasa hivi tuko kwenye SolidWORKS simulation na initially the other time tuliangalia kuhusu static analysis na ilikuwa ni static forces analysis. So tunaweza kuangalia static forces, tunaweza kuangalia static pressures na tulipata fundamentals of engineering design kwamba when we say stress, strain, when we say endurance, when we say the failures due to repeated loading, or cyclic loading, and other things like that, vitu ambavyo vinaongeza stress concentration, how to minimize them, vitu vinavyo affect performance ya structure kwa vile geometry ama material etc. So today tunaenda kuangalia kuhusu thermal analysis. This is a heat or temperature analysis and so tunaweza tukawa tuna analyze a device, either a heat, let's say a heater ama a heat sink. Okay, so tukisema a heat sink ni device ambayo yenyewe inasaidia kwenye cooling of electronic devices and other components. Lakini tukisema heater ni kwamba we generate heat and then maybe to heat the surrounding. Kwa mfano labda kwenye cold environment tutaka kupata joto tunatumia heater. Hapo unaweza kusema heater kama inayotumika kuchemsha maji. So unaweza kufanya analysis kuona how heat is distributed around the structure ama the component and how it transfers maybe from the structure or from the component to the medium, kama ni liquid, kama ni air. Okay, so we start this by this question here. So this problem says, so here we have a part. So this here is the part. So this here is a heater, but we can take it as a heat sink. So that's for the matter of understanding. So tukisema hii ni heater, manake main purpose inakuwa ni to heat the surrounding, either surrounding air ama surrounding medium kama liquid. Lakini tukisema hii ni heat sink, manake the fins and the copper here, the main purpose is to cool maybe an electronic component or device ambayo iko bonded with this old structure, so as to prevent overheating, pia ku enhance efficiency ya performance ya such a device. So this here is our device, which has a copper base and plain carbon steel fins. So for the matter of understanding, tunaweza tukatumia kama heat sink, lakini hii generally according to the problem ni heat supply ama heater, right? So you can see here from the problem, inasema an electric device generates heat at a rate of 100 watts. So this is a heat rate. So simulate and find the main thermal characteristics of a set of fins located on the top of this device. Inamaanisha this copper here is our electric device ambayo ina generate heat at that rate 100 watts. And then these are the fins on top of this device that dissipate the heat, right? Takes the heat from here to the surrounding air, right? So more or less this can be a heater, right? Okay. So anasema the surrounding air is at a temperature of 300 Kelvin. So air ambayo ina surround hii device ina move at ina temperature ya nyuzi joto 300 Kelvin. So nadhani kama ni kupata degree centigrade tutachukua 300 minus 273 tupata 27. So surrounding air ina 27 degree centigrade, right? Okay. And the heat transfer coefficient is 15 watts per meter square Kelvin. So hii ni heat transfer coefficient ya air, right? So heat supplied per area per temperature, right? So anasema from the simulation, find the temperature distribution over the surface of the object. So temperature itakuwa distributed how, kwamba in this whole surface, this as a heater, how do we expect the temperature to be distributed all over this device, taking into account the airflow that move around this device, right? Secondly, anasema the temperature gradient in the object. So temperature gradient, this is the temperature temperature per distance, right? Per length. So inaweza kwa unit in Kelvin per meter. Again, pia the heat flux. So heat flux, this is I think this is heat per area. So heat per area, it could be watt per meter square, right? Over the external surface, right? Heat per area, and this is temperature per distance. Okay, so before we go into the simulations and creating this component that we simulate, let's begin by a very short presentation on a heat sink, right? Okay. Um, so heat sink, well, so I'm taking this as a heat sink just for the most of understanding. Although here upon heater, right? Maana in reverse use kwamba ina heat the surrounding. Lakini nimeitem kama heat sink kwamba it's there to cool maybe an electronic device. Okay, inaweza kuwa na the same structure and arrangement but different purpose, right? Okay. So let's take it that the heat sink with the copper plate and the carbon steel fins. Although inaweza ikawa na one material only, labda a heat sink, a copper heat sink, right? Lakini let's see a case where we have copper and plain carbon steel fins, right? So tunaenda kuelewa design functions, advantages and applications. So okay, so this is our structure overview. So a component here, we have a copper base plate. So this copper base plate has a high thermal conductivity. As you know, generally copper has the high thermal conductivity. That's why inatumika sana kwenye electric transmission ama heat transfer, right? So in a high thermal conductivity, but pia in a high electrical conductivity, right? Goes proportional. So this here is the thermal conductivity of the copper, watts per meter Kelvin. So plain carbon steel fins, these fins. So structural support and increased surface area. So inaweza kutumika kama support ya structure, lakini pia ina increase surface area ya heat dissipation, right? So design concept of our heat sink. So efficient heat spreader. So we have a copper kwa sababu ina high thermal conductivity, inamaanisha kama tutaitumia kwenye heat sink tukiattach kwenye component, labda electronic component ambayo ina generate heat, so it will absorb the heat from that component very fast kwa sababu ya high thermal conductivity, and that's what we need for cooling, efficient cooling, right? But then if we use the plain carbon steel as the fins, then the fins will be very durable because they are steel, right? It's a structure integrity, right? So how will our heat sink work? So first we have a heat transfer flow. So heat transfers or heat enters copper base from the device. Kwa hiyo electronic device yetu labda CPU ama microprocessor kama ya kwenye computer ina generate heat, and then heat inakuwa absorbed by copper kutoka kwenye base ambayo iko bonded na hiyo device to the copper, and then from the copper spread heat laterally. So it absorbs heat and then it supplies it, like it spreads it all over, and then it goes to the steel fins. So the steel fins absorb heat and release it via convection. So unaona, so kwa sababu tunajua by nature temperature flows from high to low. So that means copper absorb heat, the heat will be transferring from high temperature region to low temperature region. So kutoka kwenye copper kwenda kwenye fins, lakini pia the medium ambayo ni surrounding air, ambayo inaweza kuwa labda kuna blower ama feni ambayo inasukuma hewa kwenda kwenye zile fins. So feni itakuwa ina take away the heat from the fins, and then the cooling becomes more efficient, right? So ukiwa na blower ama ukiwa na feni ina enhance ile cooling action, right? And then we have heat dispersion. So first, how do we disperse this heat to the surrounding, right? So sasa tumesha transfer from the component to the copper to the steel. Now how do we release it to the surrounding? So there's a tunafanya natural or forced convection to improve the cooling. So inaweza ikawa na loose into the air, and this is where kama ingekuwa device ni heater, that's how we get the heat to the surrounding air. Kwamba air blows over the fins, takes away the heat, and we feel the heat in the surrounding. But this is for cooling. Also, air blows across the fins, takes away the heat from the fins, and the cooling happens to the device. So heat to the surrounding, cooling to the device. So forced conversion manake we have a fan ama blower ambayo ina increase ile airflow rate, right? So as to enhance the cooling, improve the cooling. But then increase surface area via fins. So kwa sababu fins zinaongeza surface area, then there's a faster heat loss, right? So what are the advantages? So of our structure. So first, the copper base, right? Fast and even heat spreading. So copper base inafanya faster heat spreading lakini evenly, right? Then steel fins they are strong, they are cost effective, and they are durable. Kama tungeamua kutumia that sub-assembly as a heat sink. Lakini enhanced surface area, so better heat dispersion kwa sababu ya zile fins zimeongeza surface area, so we have a better heat dispersion. Lakini pia we have structural integrity, so withstands harsh environment, right? Kama hiyo carbon steel, plain carbon steel fins, they are integral, so zinasaidia ku withstand harsh environment, right? Kama industrial areas, etc. So what are the limitations kama tungeamua kutumia such structure? So lower thermal conductivity in steel versus aluminium or copper. So unaona kama ingekuwa ni a great heat sink ingekuwa tuna one material, let's say copper ama aluminium, right? Kwa sababu zina high thermal conductivity, so that means fast cooling, right? So heavier than aluminium only heat sinks, right? So this structure is heavier than aluminium only heat sinks. So aluminium is lighter, the conductivity is high, so better advantages. So there could be a thermal expansion mismatch kati ya copper na steel kama we decide to use it as a heat sink, lakini requires a good bonding method to avoid delamination, right? Ili structures they can detach from the copper base, right? Sababu hizi ni different materials. So where do we apply the heat sinks? So we apply it in industrial electronics, kwa mfano kwenye power resistors and converters, lakini pia tuna apply kwenye automotive control systems, high vibrational environments, but also power supplies and inverters, cooling, right? We apply the heat sinks. Bravo! So yeah, mpaka hapo nadhani una a good foundation, msingi mzuri wa sasa kwenda kufanyia our simulation, right? So ukiangalia hii structure yetu utaona kuna two components here. So this is a sub-assembly, lakini hii assembly ili tuweze kufanya simulation analysis hatuwezi tukazichora hizi components individually outside, kwamba tuchore copper to save, tuchore multi steel to save, alafu ndo tuje tufanye assembling, alafu tufanye simulation. Itakataa kwa sababu connection between these parts inaweza ikatuletea shida, so assembly inaweza isikubali. I mean simulation inaweza ikagoma kusimulate. So tutachofanya tutachora this sub assembly inside one assembly, right? So tutafungua assembly alafu tutachora these parts inside that assembly, right? And then tutafanya simulation from there. Okay, so tukifungua hapa SolidWorks, so let's say file, say new, so new assembly. Okay, so we go to new assembly, so close this one and close this one. So what we do, tunakuja hapa kwenye insert component, tunasema new part. Utaona hapa imetokea new part, so click anywhere here inside. Okay, so utaona hapa we have part 1, assembly 1. So here tunaweza kuja sasa kwa sketch your part. So let's begin by sketching the copper. So the copper, so copper iko na diameter ya 100 na thickness ya 20. So let's draw it on the top plane, right? Diameter 100, thickness ya 20. So we come here to top view, sketch. So let's draw this cycle. So smart dimension. So this is 100. Okay. And after this 100, so hii hapa tunakuja tuna extrude. So hii hapa tunakuja tuna extrude kwa how much? Kwa 20. So tuna extrude kwa 20. So tunakuja hapa kwenye okay. Okay. No, discard this. Discard the changes. So okay, let me delete this. Right click, say delete. Okay. So right click here. So ukija kwenye top plane. So ukisema so tumesema unakuja kwenye insert. So kuja kwenye assembly unasema insert. So unasema new part. Okay, una click anywhere here. So what you do is you click this component and you say edit part. Okay, so ukisema edit part, this is where now you come to the top plane, say sketch, right? Then you come to the unachukua cycle. So cycle hapa ilikuwa ni ya 100. So smart dimension hii hapa ni 100, enter. Alafu hapa sasa tuna extrude kwa 20. So 20, right? So unaweza kuweka hapa isometric view. So hii hapa tunaweza tuka extrude downward ili tuje tuchore ile other part exactly on top of this feature. So tunaweza tuka flip direction hapa. So flip direction manake you see tutakuja kuchora ile part ya plain carbon steel on top of this copper feature. So check, and then hapa nasema save part, right? So hapa tunayo our lower copper part. So that's part T. So hapa imepewa part 2, right? Hiyo ni part yetu part 1 ambapo hapa imepewa part 2 as just as a name. So baada ya hapo tuna create tena. So tunakuja kwenye hii part ya juu ambayo ni plain carbon steel fins. So hiyo part unakuja tena kwenye insert component, unasema new part, and then you click anywhere here. Then you click this new part and you say edit part. Now you come to the top plane, you say sketch and you say normal 2. So hii heat sink ya plain carbon steel hapa ina diameter 120 na thickness yake ni 20 hapa mpaka hapa 120 kwa 20. So let's draw that first. So cycle. So hapa ni smart dimension. So this here is 120. Check. And then extruded base. So symmetric view. So we extrude it by 20. Check. Okay. Then we have to draw our fins on top of this. So sketch on this. Normal 2. So tukiangalia easy fins. So you see distance from the center here to the to this edge of this fin itakuwa ni 105 gawanya kwa 2, which is 52.5, right? Kutokea hapa katikati mpaka hapa kwenye edge itakuwa 52.5, na hii fin ina thickness ya 5 na ziko 1 2 3 4 5 6, right? Ziko 6. Lakini ukiangalia this, okay, so let's draw kwanza hiyo fin ya kwanza kabisa. So tunaweza chukua hapa corner rectangle, so tukai sketch corner rectangle here like this. Yeah, so smart dimension, so kutokea hapa center mpaka hapa kwenye edge, so hii hapa ni 52.5. Oh, control Z. 52.5. Oh, control Z. 52.5. Yes. And this thickness here is 5. Yes. So baada ya hapo ziko how many items? So tunaweza kufanyia linear pattern. So ziko 1 2 3 4 5 6. The distance between the item to item, so inakuwaga from a center of one item to a center of other item. So to the center of this item ni 2.5. At the center of this item ni 2.5. Namaanisha kama edge to edge ni 15, so center to center itakuwa 2.5 plus 2.5, so itakuwa 20 to 20. So center to center for the pattern is 20. So distance between the component will be 20, 6 components, right? So hapo utakuja kwenye linear sketch pattern, tuta click this one. So distance hapa ni 20, 20, na items ziko 3, 4, 5, 6. Then check. Baada ya hapo tunaweza tukaclick hii cycle tukasema convert entities, so baadaye tutakuja tukasema trim, so tukatrim hizi entities, right? Tukatrim hizi entities, right? Tukatrim pia hizi, right? Trim hizi entities, tukatrim pia this one, 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 trim pia this one. Yeah. So isometric view. So there we have our fins. So baada hapo sasa kasema features, kasema extruded base. So extrude kutokea hapa mpaka hapa ni 100. So extrude it by 100. 100. Then check. Yeah. So there we have our component lines. They say save. Okay. Okay. So baada hapo tunasema control S. So save all. So there's a save desktop. Right, so naweza andika hapa labda hii ni thermal analysis, then nikasema save. So this assembly unsaved visual components, so naweza ka save externally as the name suggests. So save externally, specify parts and then okay. Okay, so mpaka hapo tumeshakuwa na our sub assembly of the copper base plate na plain carbon steel fins, right? So what next? So as usual tunakuja SolidWORks add-ins, tunasema SolidWORks simulation. Okay, then simulation. So nitasema hapa new study. So hapa uta click thermal, right? So uta click thermal, then let's say it's thermal analysis. Then check. Okay. Baada ya kucheck hiyo, so tuna apply material. So unaweza kuja hapa kwenye parts, ukaja hii part 2. So part 2 ni ya chini. So part 2, right? Unaweza apply material. So okay, class here. So unaweza ukaclick hii part, ukaclick part 2, ka right click, ukasema apply material. So unaweza ukasema apply favorite material kama zipo kwenye list. Kama zipo utaenda kwenye apply material generally. So ukija hapa kwenye apply favorite material, so hii ya chini hapa ni copper. So select copper, right? alafu uta click hii part 3, uka right click tena, ukisema hapa apply favorite material, we have here plain carbon steel. Yeah, so we have our materials already. Tuna copper base, alafu tuna plain carbon steel as the fins, right? Then after that tukija kwenye connections, so kwenye connections, so ukija kwenye sababu tuna sub assembly, so kwenye connection hapa tuta right click, tutasema contact set, so tuta select face ambazo zina contact, so we know for sure this face is in contact with the other face, so hapa not this face, so uta right click hapa, so that's face 1 hapa. Hii ni face 1 kwenye part 3, lakini kwenye part 2 uta right click hapa, utasema select other, maana yake select the other face ambao ni this face, ambao ni face ya juu. Kiselect ya chini is not the one, the other face. So hapa chini, hii hapa ni nasema ni thermal resistance, right, between components, kwa sababu hizo component ziko mbili. So tusema thermal resistance hapa between the two components, maana yake ni difference in temperature between the components, right, per unit area, right. So per unit heat transfer, so in Kelvin per watt per unit heat transfer, kwamba temperature difference between the two components per unit heat transfer. So sometimes unaweza kusema tu ni zero resistance, there is no resistance, lakini kwa sababu hapa hizi component ni tofauti, kama ingekuwa copper to copper tungesema zero resistance kwa sababu they are the same material, lakini kwa sababu ni copper to plain carbon steel tunaweza kadiria resistance hapa, tunaweza kusema ni let's say 0.01, so 0.01, then check, right, so asymmetric view. So after that tunakuja hapa kwenye thermal load, so una right click, so we apply thermal loads. So thermal load ya kwanza tuna apply hapa ni say heat power, right, so heat power SI unit, natumia SI unit. Heat power ilikuwa ni ngapi? So according to our question here, so tulikuwa na heat power of 100 watts, right, so 100 watts, so hapa tunaandika 100 watt, right, then hii heat power ilikuwa inakuwa applied to the copper base, si ndio? Sababu copper base ndio ilikuwa kuna heat power, si ndio? According to here sema heat at this rate, right, at the copper part, si ndio? So it generate heat at the copper part, so the copper generate heat at 100 watts, so check. After that we know we have, so right click here again, say convection, so tuna convection. So convection, so first we have a convection coefficient of our air. So convection coefficient ya air hapa tuliambiwa ni 15. So okay, convection heat transfer coefficient 15 watt per meter square Kelvin. So hapa hivi tunaandika ni 15, right? Na hapa chini kwenye bulk ambient temperature, so tuliambiwa surrounding air ina 300 Kelvin. So hapa ni 300 Kelvin. Then here tunasema select all exposed surface, kwamba this all component is exposed to the surrounding air. So not just this, not just that, not just that. So all this whole component here inapita all this, around all this. So unasema select all exposed. So all exposed surfaces equal exposed to air. So then hapo utasema check. Okay, so here we don't need to do the meshing. Hatuna haja ya kufanya meshing kwenye hii assembly to avoid the complications and simulations errors. So utakuja hapa tu kwenye hii utasema run this study. Boom, there we have it. This is a result of our simulation. So tunaweza hizo dot tunaweza tukazitoa. Kwa mfano ukija hapa kwenye thermal loads tunaweza ukaclick hii convection ukasema hide, right click hide, na hii hapa pia ukasema right click hide. So tuna hide hizo, yeah. So alikuwa anataka nini kwenye swali? First alikuwa anataka temperature distribution over the surface, then temperature gradient, then heat flux. So kwenye result, so hapa tayari tuna temperature distribution, right? So tunaweza right click hapa tuseme define thermal plots, tuseme hapa ni tunataka kuangalia resultant temperature gradient, that's what we want. So naweza ikawa temperature gradient along x, along y, along z, but we want the resultant one in Kelvin per meter, right? Then tunasema hapa check, lakini pia right click, define thermal plot. Also tunataka kuangalia resultant heat flux, check, si ndio? So tukija hapa tukishow, so ukiangalia kwenye thermal, right, this is temperature distribution, right, temperature distribution. So as you see, tunaweza tukaja hapa kwenye tuka right click hapa, tukaja kwenye chart options, tukasema, tukashuka hapa chini tukasema general, then check, yeah. So temperature distribution hapa unaona kelvins, lakini unaweza right click hapa tukasema chart options, tukazika kwenye degree centigrade ili tuone so definition, let's say Celsius, then check, yeah. So you see here, our very hot surface is the copper plate with almost 84 degrees centigrade copper surface. And then we see more heat will be on the copper surface. Then in between this area here, will have distribution of most of the high temperatures will be along this region. And then list of the temperatures itakuwa around at the top. So manake unaona temperature na flow from high temperature region to low temperature region of your heat sink, right? Ama heater, kama ni heater kama hii. Lakini hapa ukija kwenye show, so resultant temperature gradient, so we see more temperature Kelvin per meter, right? So more temperature will be lost, will be transferring around this region. So this is the temperature flow per meter. So unaweza uka right click hapa ukasema chart options, okay, ukaja hapa kwenye definition advanced ukasema show vector plot, ukasema check. So utaangalia hapo unaona you see the temperature, how temperature flows, right? So you see more temperature at the more temperature per meter around this area, as you see by the color of the arrows, right? But then we have thermal heat flux. So tusema heat flux ni temperature per and heat per area. So you see we have more heat dispersion per unit area around this region, right? Around this region, the mid region. So unaweza ukaja hapa uka right click ukasema chart options, ukaja hapa kwenye definition ukasema advanced, ukasema show the vector flow, ukasema check. So you see here heat flows upwards, right? Heat flows upwards, right? So kutokea kwenye kwenye copper plate kwenda kwenye plain carbon steel fins, lakini you see more heat flows, more heat per area happening around this region according to the colors of these arrows, right? Okay, so I hope umeelewa sana kuhusu thermal analysis. Nadhani umejifunza vitu vingi kwenye thermal analysis. Yeah, so unaweza ukabadilisha material, unaweza ukafanya copper to copper, ukaangalia results, ukaangalia how temperature is distributed, ukaangalia how ukaangalia temperature gradient, lakini pia ukaangalia heat flux, heat per area, right? So yeah, keep pushing, you're in the right direction, you are heading somewhere great, and I'll see you in the next season, and I'll see you in the next lesson. Ciao.